Now it's time to talk about definite integrals and substitution. Everything up until now has been indefinite integrals plus c, because you're not evaluating over a specific interval. And so now we're talking about definite integrals. And it's really the same game as before. The methods, the techniques are the same. It's just as to how you evaluate the definite integral that where there are two methods. Both are important, so learn and understand both. And having a favorite is totally fine. I definitely have a favorite. But know and kind of be comfortable that there is another method, because sometimes you do need one or another. And I added a comma there to make that sentence more grammatically correct. So one method is to always use, or rather to return to the original bounds. That says leave the limits of integration in terms of the original variable and then evaluate the integral as if it were an indefinite integral and back substitute so that you get the expression you're evaluating in terms of the original variable, and then use those original bounds. The second method is to change the bounds on the integral, the limits of integration, to the two terms of the variable of substitution, and usually u. So I guess there should be I was all about making mistakes on this slide. Again, reading that, hearing it, probably not the best. Let's run through an example. And actually, I'm going to do this one first and this one second in the next couple slides. So our example, both ways. The first one, new limits of integration. Change your limits of integration into terms of u. So let's make our u substitution. I see 2x to the third power plus 1. Well, x to the third power has x to the second some flavor of as its derivative, so that's going to be our choice of u. So let's first make our substitution and rewrite our integral. So our u substitution is going to be u is equal to 1 plus 2x to the third power, and then du dx is equal to 6x squared, which gives us that dx is equal to du over 6x squared. So now we're going to use this substitution to rewrite our integral. The integral from, and I'm just going to put little question marks here. The integral from question mark to question mark, if we make this u substitution, becomes x squared times u now to the fifth power times du over 6x squared. Tidy up the x squareds, reduce away. So our integral in question becomes from unknown bounds of integration, u to the fifth, 1/6 out front to account for this 6 here, 1/6 u to the fifth du. Okay, so now we are going to come back to that. So the game here is, what are these limits of integration going to be? And so what we do is we start with x equals to 1. Let me do this. No, it's fine. X equal to 1. Well, our substitution is u is equal to 1 plus 2x to the third power. So what is u going to be when x is 1? U is equal to 1 plus 2 times 1 raised to the third power. That gives us 3. So this tells us that x equals 1 will be the same as u is equal to 3 under our substitution. And x equals to 0 becomes u equals 1 plus 2 times 0 to the third power equals 1. So x equals to 0, that is the same as u is equal to 1. And these are our new limits of integration here. So under this substitution, our integral becomes, our lower limit used to be x equals 0 is now u is equal to 1. And I'm going to actually write u equals here, just to really emphasize that we're using u here. And the upper limit, which used to be x equals to 1, is now u is equal to 3. Okay, so now, what about the rest of the integral? Well, we got that 1/6 out front that I nearly forgot about, and then u to the fifth du. So now this becomes an integral we can do. This is 1/6 times u to the 5 plus 1 is 6 power times 1 over 6. And we're going to evaluate this thing, again, emphasizing that these are now in terms of u. U equals 1 to u equals 3. So we got 1 over 36. This is equal to 1 over 36 times the top guy, 3 raised to the 6th power, minus 1 over 36, u equals 1, u equals 1 raised to the 6th power there. Do a bunch of algebra, and you come up with 182 over 9. So that's a fine way to do this, but I want to show you that you can get the same answer without doing that. And the part we're going to do is we're going to effectively kind of skip this stuff, and we're never going to adjust our limits of integration, and I'm just going to use a little kind of notational shortcut to keep track of the fact that my limits are not in terms of u. So again, our substitution is going to be the exact same as we did above. U is equal to 1 plus 2x to the 3rd power. This time we're going to use the original limits of integration. We're not going to change them. They're going to be in terms of x still. And so then our derivative became dx is equal to du over 6x squared. I skipped a little bit of algebra there. So now making this substitution, our integral becomes 1/6 out front, u to the 5th power du, just like on the prior slide. However, now our limits of integration are not correct. I don't want to put 0 and 1 in here, so I like to put 2 little dots. And that's to say, hey, don't worry about these. And this isn't in any textbook. This is just kind of my method here. If you write 0 or 1 here, you really should put x equals to 0 so that you don't accidentally evaluate the integral in terms of u using x variable limits of integration. So I just put 2 dots, and that's to remind me to back substitute at the end. Okay, so we do the integration, and that's going to give us, just like before, 1 over 36 u to the 6th power evaluated from dot to dot. Again, keeping those, because those limits of integration are not in terms of u. We don't want to accidentally plug them in. So you could even write something like x equals 0 or x equals 1, and then there's your cue that, oh yeah, I got to back substitute, just like we had been doing with indefinite integrals. 1 over 36, let's do it. Let's back substitute. Times the quantity 1 plus 2x to the 3rd power raised to the 6th. And now I can evaluate this thing from x equals 0 to x equals 1. And so to do that, we've back substituted so that our resulting integral is in terms of the original variable, so I can use the original limits of integration, which are in terms of that variable. So now for x equals 1, we get 1 over 36 times 1 plus 2 times 1 to the 3rd power. Whoops, got a little overzealous there. 2 times 1 to the 3rd power, all raised, that entire expression raised to the 6th power. Now we'll subtract away that expression evaluated at x equals 0, 1 over 36 times 1 plus 2 times 0 to the 3rd power, that whole thing raised to the 6th power. And once again, because the point of this is not to show you the algebra here to simplify that expression, which we're capable of doing, but rather to emphasize that either way you do it, you get the same result.